So when you check now, I will show it to you later.
Later.
Okay, so what can I do now?
See, what I'll suggest is the best thing would be that you just open any chapter, like study or compound any chapter, and just practice the questions of concise from those PDF. I think that will be better because the questions which come are normally like the ones in concise.
Like the exercise questions.
Yeah, the ones which are there in that. Okay, good evening all of you. Today we are going to do definite integration and application of integration. Okay, now you all have a fair idea about integration, all the techniques, by parts, partial fractions, substitution, etc. In definite integration, what happens that there are some properties, okay? So you know that there are some functions which are integrable, there are some functions which are not integrable. But in definite integration, what happens is that we have uh, functions which are at times not directly integrable, but we can use some properties and make it integrable. Now let's have a look at this question. Integral a to b fx dx is equal to integral a to b fy dy. This is the question. So a to b fx dx is a to b fy dy. So what is the property? That if the name changes from x to y, the answer will remain the same. So if the name is x and here the name is y, there is no difference. Both of them are the same. So integral a to b fx dx is a to c fx dx plus c to b fx dx. So c is a number between a and b. So if you integrate a to b fx dx, it is a to c fx dx plus c to b fx dx. And c is a number between a and b. This is property number 2.
আমার একটা ফ্রেন্ড আমাকে জিজ্ঞেস করছে যদি কেউ একটা সাবজেক্টে ফেল করে যায় তারপরে রিটেস্ট দেয়, অ্যানুয়ালসের পরে রিটেস্ট হয়, অ্যানুয়াল এক্সাম যেদিন শেষ হয় ওই দিন তো স্কুলটাই বন্ধ হয়ে যায়। এরকম না, হ্যাঁ স্কুলটা বন্ধ থাকে, তারপরে একদিন রেজাল্ট যাবে, তারপরে সোজা কেটে না সিবিএসসি কোনো পরীক্ষা না না পুরো ইয়ার হয়, বাট অ্যানুয়ালসে তো বলছে অ্যানুয়ালসে এমন কি দরকার পড়ে আমাকে রিটেস্ট দিতে হবে, জানি না কিছু পড়েনি অমনি।
So integral a to b fx dx is negative of integral b to a fx dx. So this is change of limit. So if the limit a to b becomes b to a, there will be a minus sign. Now these three properties, they are almost, you can say they are almost obvious. So there is no need to even talk about any proof. Okay, these are almost like obvious properties, so there is no need to talk about proof. Okay, then Okay, now property number 4. Integral 0 to a fx dx is equal to 0 to a f of a minus x dx. So how to prove this property? Suppose a minus x is y, so dx will be minus dy. So replace dx with minus dy, replace x with a minus y. When x is 0, y is a. When x is a, y is 0. So the limit is a to 0 with a minus. So remove the minus and make it 0 to a using property 3. So using the property number 3, this a to 0 becomes 0 to a, and using property number 1, like the y changes to x. So this is the proof of property number 4. See, one thing I want to tell all of you, that property number 4 is by far the most important property, and you are guaranteed to get a question from property number 4 in your board exam. So 0 to 2a fx dx, y is 0 to a fx dx. So if f of 2a minus x is fx, then the answer will be, if f of 2a minus x is fx, the answer will be twice 0 to fx dx. And if f of 2a minus x is minus fx, the answer will be 0, right? So 0 to 2a fx dx is 0 to a fx dx plus a to 2a fx dx. Now let 2a minus x equal to y. So 0 to fx dx plus, now 2a minus x is y. So dx will be minus dy. So you remove dx and put minus dy. So you remove, if you put x equal to a, then y will be a. If you put x equal to 2a, y will be 0. F of 2a minus y into minus dy. So now what I'm going to do is I'm going to change the limits, like a to 0 will become 0 to a, f of 2a minus y dy. So now I think it's pretty obvious that if f of 2a minus x and fx both are same, that means these two will become same, so answer will be double of 0 to fx. And if f of 2a minus x is negative of fx, these two will cancel out and the answer will become 0. So that is how you have to do some number, formula number 5. Okay, then we come to property number 6. Minus a to a fx dx is twice 0 to a fx dx if fx is even, and it is 0 if fx is odd. So minus a to 0 fx dx plus 0 to a fx dx. So you just put x equal to minus a. Sorry, just put x equal to minus y. So if you put x equal to minus y, then minus a will become a, 0 will remain 0, f of minus y minus dy plus a to 0 fx. Then you change the limit. So you change the limit, a to 0, make it 0 to a. So this minus sign will be removed, 0 to a. Now 0 to a f minus x and 0 to a fx. If fx is even, they both will get doubled up. If fx is odd, they both will cancel out. So the question number 6, if fx is even, both will add up and become double. If fx is odd, they will cancel and become 0. So this is property number 6. So integral a to b fx dx is integral a to b f of a plus b minus x dx. So integral a to b. So if you put x equal to a, then y is b. If you put x equal to b, then y is a. F of a plus b minus y and minus dy. So integral a to b, f of a plus b minus y dy. So integral a to b, f of a plus b minus x dx. So this is the proof of property number 7. Integral a to b fx dx is equal to integral a to b f of a plus b minus x dx. This is property number 7. Now there is another property, that is property of periodic function. That one is definitely not any chance of coming in your board exam. School exam is anybody's guess, but in your board exam it won't come. So let's have a look at that. So this is the property 0 to na fx dx is n times 0 to a fx dx. This is the property. So how do we prove this? So 0 to a fx plus a to 2a fx, and last one is n minus 1 a into 2na fx. So 0 to a fx, then the period of this function is a, that means f of a plus x is equal to fx. So it will be integral 0 to a f of a plus y dy, and you can make similar substitutions in the other integrals. Now the point is 0 to a fx, 0 to a f of a plus y. So you can make similar alterations in the others. So 0 to a fx, 0 to a f of a plus y, etc. So all of them, due to the periodicity, will become 0 to a fx. So 0 to a fx, 0 to a fx, 0 to a fx n times. So answer will be n times 0 to a fx. This is property number 8. Now, what is the use of properties? What is the use of properties? So suppose you have a sum like this: 0 to pi by 2 sin x by sin x plus cos x. Okay, suppose you have a sum like this: 0 to pi by 2 sin x by sin x plus cos x. So In this sum, so it will become sin pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x. So I is 0 to pi by 2 sin x by sin x plus cos x, I is 0 to pi by 2 cos x by cos x plus sin x. So if you add both of them, so 2i is 0 to pi by 2 dx, so that is pi by 2. So I will be pi by 4. So this is just to show you why property number 4 is the most important property. You can see that a very big sum like sin x by sin x plus cos x, thanks to property number 4, the sum has become very manageable. The answer is I equal to pi by 4. So a very big sum has become a very small sum thanks to the property. Okay, then have a look at this question. Suppose you have integral pi by 6 to pi by 3 sin x by sin x plus cos x. Suppose this is the sum. So what you have to do is the limits will be pi by 6 to pi by 3 by using property number 7. This will be sin of pi by 3 plus pi by 6 minus x by sin of pi by 3 plus pi by 6 minus x plus cos of pi by 3 plus pi by 6 minus x. So this will become integral pi by 6 to pi by 3 cos x by cos x plus sin x. So suppose you call this as I, suppose you call this as I. So if you add both of them, so integral pi by 6 to pi by 3 dx is pi by 6. So I will be pi by 12. Okay. So 2i will be integral pi by 6 to pi by 3. So that is coming to pi by 6. So I will be pi by 12. So this is another example of property number 7. Okay, so suppose if you have a sum like this, integral cos cube x from minus pi by 2 to plus pi by 2. Suppose you have a sum like this, so you know that I am making it sin cube x. Suppose you have a sum like this, integral sin cube x from minus pi by 2 to plus pi by 2. Okay, suppose you have a sum like this. So in this sum, this sin cube x is an odd function and the limits are minus pi by 2 to plus pi by 2, so the answer will be 0. So according to property number 5, property number 6, because the limits are of the nature minus a to a and this is an odd function, the answer will be 0. Okay, now at school level, the most important sum is 0 to pi by 2 log sin x. Okay, so at school level, this is considered to be the most important sum. So it is 0 to pi by 2 log sin pi by 2 minus x. So 0 to pi by 2 log cos x. Okay, so 0 to pi by 2 log sin x, that is 0 to pi by 2 log sin pi by 2 minus x, that is 0 to pi by 2 log cos x. So 2i will be 0 to pi by 2 log sin 2x by 2. So 2x is y, so x dx will be half dy. So it will become 0 to pi log sin y dy by 2 minus 0 to pi by 2 log 2 dx. So this is twice 0 to pi by 2 log sin y by 2 minus pi by 2 log 2. So ultimately this is 2i and this is I. So 2i will be I minus pi by 2 log 2. So I is coming to minus pi by 2 log 2. Now at school level, this is the most difficult sum. So 0 to pi by 2 log sin x. So 0 to pi by 2 log sin pi by 2 minus x. So 0 to pi by 2 log cos x. So if you add both of them, 2i is 0 to pi by 2 log of sin x plus cos x by 2, that is log sin 2x by 2. So if you take 2x as y, then x dx is half dy. So 0 to pi log sin y divided by 2 minus 0 to pi by 2 log 2. So this is double of 0 to pi by 2 log sin y half dy minus pi by 2 log 2. So 2i is I minus pi by 2 log 2, so I will be minus pi by 2 log 2. So this is at school level considered the lengthiest possible sum that you can get from properties of definite integral. See, one important thing you will have to keep in mind whenever you are doing a sum of definite integral, one important thing that you will have to keep in mind is what happens when you make a substitution. Suppose you are doing a sum like this, 0 to 1 x log x plus 2. Suppose you are doing a sum like this. So you put x plus 2 equal to y square. So dx equal to 2y dy. So if you put x equal to 0, and y will be root 2, and if you put x equal to 1, then y will be root 3. So this is something you have to remember, that whenever you are doing a sum of definite integral by using a substitution, so you are doing 0 to 1 x log root x plus 2, you are substituting x plus 2 equal to y square. So then automatically dx will be 2y dy. So you have to replace dx with 2y dy. X will be y square minus 2 and this will be log y. Now I am not doing the rest of the sum because it's just a normal by-part sum. But the important thing is that the limits have changed. So when x is 0, y is root 2, and when x is 1, y is root 3. So that is an important thing you have to remember, that whenever you make a substitution, the limits will change. Okay, that is important. Okay, next we come to integration as limit of a sum. So suppose this is the graph, and you are integrating the graph from x equal to a to x equal to a plus nh over b, and basically what is happening is that you are dividing the graph into infinite strips. Okay, the number of strips tends to infinity and the thickness of each strip tends to 0. So you are dividing the graph into infinite strips. The number of strips tends to infinity and the thickness of each strip tends to 0. So the area of the first strip will be thickness of the strip into the height, so h into f of a plus h. The area of the second strip, h into f of a plus 2h. And the last strip will be h into f of a plus nh. So the total area will be h into summation r equal to 1 to n f of a plus rh. This will be the total area. So this formula h into summation r equal to n f of a plus rh, this formula is called integration as limit of a sum. Actually, yes, thank you for your query, Aditya Sarah, thanks for your query. Actually, you know very well that in the language of calculus, we don't say things like equal to 0, we always say tends to 0. So, your question is very appropriate. There's nothing wrong with your question, but in the calculus language, we don't use equal to 0. We don't say like that, equal to 0. So we say tends to 0. So in the calculus language, if there are infinite strips, the number of strips will tend to infinity and the thickness of each strip will tend to 0, right? So there will be infinite. So the point is that if each strip is almost equal to 0, then we are right in saying there will be infinite strips. But if you say exactly equal to 0, then though you will not get any diagram. And you are aware that that is what we do in calculus. We don't say equal to, we say tends to 0. So that is why you have infinite strips. Each of them tends to 0, and like infinite strips, total area is this. So this technique is called integration as limit of a sum. Okay. Now you all must know one thing, that area under the graph between two limits is denoted by the definite integral. So this area is integral a to b fx dx. So if you do integral a to b fx dx, you will get the area. If you do h summation r equal to 1 to n f of a plus r is, then you will get the area. So whether you do this or this, both the ways you will get the area. But this is actual definite integral, whereas this is limit of a sum, right? Okay, now suppose if a is 0 and b is 1. Let us say a is 0 and b is 1. If a is 0 and b is 1, then nh will be equal to 1. So it will become 1 by n summation r equal to 1 to n f of r by n. So if a is 0, b is 1, nh is 1, then 1 by n summation r equal to 1 to n f of r by n. This will be the answer, right? So in a general sense, this is the answer, and specifically if you take a equal to 0, b equal to 1, nh equal to 1, then 1 by n summation r equal to 1 to n f of r by n will be the answer, right? So let us do one thing. Let us see one sum of this type. Let us see one sum of this type, and then after that, depending on how much time we have, we can just try one or two sums of actually finding the area. Suppose in this sum 0 to 1 e to the power x, a is 0, b is 1, rh is 1. I mean nh is 1. So f of a plus rh will simply be f of rh. So if you put r equal to 1 to n e to the power h e to the power 2h up to e to the power nh. So limit h tends to 0, h into e to the power h into e to the power nh minus 1 by e to the power h minus 1. So nh will be 1 and e to the power h minus 1 and h on top, this will be 1. So answer is e to the power 0 into e minus 1. So answer is e minus 1. So this is a very straightforward example of usage of this formula, right? So I take a as 0, b as 1, so nh will be 1. So limit h tends to 0, h summation r equal to 1 to n f of rh. So limit h tends to 0, h into e to the power h, e to the power 2h up to e to the power nh. So limit h tends to 0, h into e to the power h into e to the power nh minus 1 by e to the power h minus 1. So e to the power 0 into e minus 1, that is e minus 1. So that is the answer of this sum. Okay, next let us try a sum using that formula where a is 0, b is 1. So limit n tends to infinity, n by n square plus 1 square plus n by n square plus 2 square, and last is n by n square plus n square. So limit n tends to infinity 1 by n, 1 plus 1 by 1 plus 1 by n whole square plus 1 plus 2 by n whole square, etc. So 0 to 1 dx by 1 plus x square. So tan inverse x from 0 to 1. So if you put x equal to 1, the answer is 5 by 4. So this particular sum, the answer is 5 by 4. So this is an application of that sum where a is 0 and b is 1. Okay. Okay, now suppose there is a sum that there is a parabola y equal to 2x minus x square, and there is a straight line. There is a parabola y equal to 2x minus x square, and there is a straight line y equal to minus x. So you have to find the area between them. So 2x minus x square is minus x. So x square minus 3x is 0. So x equal to 0 or 3. So that means this point will be 3 comma minus 3, this point. So if you do 0 to 2, 2x minus x square, okay, that will give you this area. So the formula for finding area, like I told you earlier, it is simply integral of fx from between the limits. So integral 2x minus x square from 0 to 2. So after calculation, this will come 4 by 3. And then, so suppose you want this area. Suppose you want this area. So for this area, you will have to integrate the curve. And that has to be subtracted from the line. So you have to do line minus curve. That will give you the answer. So this one will be minus 9 by 2 and this one will be modulus of x square minus x cube by 3 from 2 to 3. Now why am I putting a modulus? So I am putting a modulus because there is a chance that the area may come negative because area uses coordinate geometry, so it may come negative. So as a calculation, this is 9 by 2 and the other one will be 4 by 3. So 9 by 2 minus 4 by 3. So the final answer will be 4 by 3 plus 9 by 2 minus 4 by 3. So that means the final answer will be just 9 by 2. Okay, now suppose you are given a sum, find the area enclosed by x-axis, y-axis and y equal to root over 1 minus x square. Suppose this sum is given to you. So in order to do this sum, you can either do integration x dy from 0 to 1, so that is 0 to 1 root over 1 minus y square dy. So this is the formula to find the area 0 to 1 1 minus y square dy. So when you do x dy, you are actually finding the area with respect to the y-axis. So 0 to 1 root over 1 minus y square dy. So y by 2 root over 1 minus y square plus y square by 2 sin inverse y. If you put 1, then this will become half into pi by 2. If you put 0, the whole thing will become 0. So finally the answer will be pi by 4. So that is the answer of this question. So integration, so the area under the graph, root 1 minus x square from 0 to 1, the answer will be pi by 4. Right? So that is the answer. So what have we done today? We have done properties of definite integral, all the 8 properties. We did 1 or 2 important sums of all the properties, whichever is the main properties. Then we did the concept of integration as limit of a sum, like both the varieties, like the general one and the special one where a is 0, b is 1. And finally we did the concept that integration can be used to find the area under a curve. And for area under the curve, general formula is y dx if it is with respect to x-axis, but if it is with respect to y-axis, then it is x dy. So we have completed definite integral and areas, both the topics, and next session, that is next Monday, we will be doing differential equation. That is the topic. So on that note, I'll end this session. Thank you. Bye all of you.